Hello guys, welcome to the channel. I hope you all guys are fine and doing great. Today we are going to discuss this number of subarrays with AND value of k problem of Leetcode. This is a hard problem. Comes in by weekly contest 134. Okay, so before starting this, I just want to let you know that I am starting a challenge. Final75 countdown 2000. This challenge I start when I was at streak of 925. Now I have streak near 1000. So to complete it to make a 1000 days streak, I just start a challenge for last 75 days where I will update my LinkedIn daily and post regarding daily problem and contest. So here this is all my journey, like when I start and why, all these things. So you can follow me on LinkedIn as well. Okay, so to know more about my journey, how I reach 1000 day streak. Okay guys, so let's move on to the problem guys. So here what we basically given, we are basically given an array nums and an integer k, and we need to find the subarray of nums whose AND value is equal to k. Okay, now let's come to whiteboard. This is a subarray given to me. This is a subarray given to me. I need to find a subarray. This is an array, and I need to find subarray whose AND value, whose AND of this particular subarray value equal to k. Now guys, now see, first point to me is, suppose if my starting point is this is my starting index, and this is my ending index. This is my ending index, and this particular subarray and equal to k. So this is my one subarray starting from index s, ending at index I. Now suppose, like take example 2, no, 2, 3, 2, 2. I need to find, starting from here, the number of subarrays starting from here, only for this index I am talking about, starting from here, that have and is equal to 2, that have and is equal to 2. So one subarray is this 3 2 and is equal to 2, this, this. So starting from a single point, I can have multiple subarray. Okay, so this is my ending point 1, ending point 2. Means this is my starting of my ending point. Like this is first subarray starting from 3, whose and equal to k. This is my k. Now this E2 index is my last index starting from this S. If I am coming here, this is my last index till this subarray value is equal to 2. Like suppose here 1, then value of this particular and value of this particular will be 0. Okay, so I cannot take this. So this is my E2. Now for this, starting from this particular index, how many subarray I can have that have value of and equal to k? E2 minus E1 plus 1. Number of subarrays. Number of subarray, how? Subarray 1, 2 and 3. Okay, basic. I can have one ending point here, one here, one here, to E2 minus E1 plus a number of ending point possible. These are the number of, so these are the subarray. If I found this value, okay, first point is here. Now I found this value E2 minus E1. This is endpoint 2, endpoint 1 plus 1 for all my I, for all my start, for all my I means for all my starting index, and I can add them and I will go to my answer. That's simple. Okay, this is the approach I will follow. Now how to find this E1 and E2? Now guys, I can find them using my binary search. Because why binary search? Now see, suppose this is my AND value of any subarray A, B, C, D, E. Okay, this is my AND value, or instead of A, B, C, just take A1, A2, A3, A4. Now guys, one thing we know here, AND value A1 will be greater than or equal to AND value A2. AND value A2 will be greater than A3, and AND value A3 will be greater than A4. Because and when we increase our range, when our range increase, our AND value decrease. We can see in above example as well. The AND value of this 3, then 2, 2, 2, then it will become 0. So 3, 2, 2, 2, 0. So AND is decreasing. Okay guys, so I know I have a decreasing array. So I can easily implement my binary search. Now how to implement my binary search? Third step, finding E1, finding E1, finding E1. Now how to find my E1? Starting from this particular index S, take a name it I. Starting from this particular index I need to find the first index whose and equal to k, whose and equal to k. Now I can simply, what will be my range? My range will be from I, like this part. Suppose if this is equal to k, so this is the first index itself. Like if my array is this and my k is this, then this particular index, this particular single element will be equal to my k. So this is the first index, and last index will be this. Last index, last index will be this. Okay, r is equal to I, r is equal to n minus 1. I need to check till last. This will be my range. Now guys, I will find out m. Now I will find out my m. Now I will have three cases. The and, this current, I will name it current. Now what is this current? Current is the and value from my index I to my index m. Means I need to start from here. My, this is my n minus 1th index. This is my n minus 1th index. This is my m index. So and of this particular value, and of this particular value, this is my current. This is my starting point I. This is my current m. This will gonna change. This will gonna change the range. Now, if this, I will name it CA. I will name it CA. Current is CA. If my CA is equal to K, then what does it particularly mean? It means my current index m can be a possible answer. Can be a possible answer. So what I will do? My answer means my even can be equal to, my even can be equal to m. Now what I need to do? I know this particular subarray and value equal to K. So what I need to find out? I need to find out is right. So I will decrease my R range. I will decrease my R range. R will be m minus. I will decrease my, I will need to search till here. Now, if CA less than K, if K is greater than my CA, now what I need to do? This particular value is less than K, I need to increase it. So for increasing my AND value, what I need to do? I need to decrease my range. I need to decrease my range. Means I again need to come here. I again need to come here. Again need to come here. So I will decrease my range because I above explained more range, the sum the value and will be less. The small the range, the and value will be greater. I will decrease my, I will decrease my R value. Okay. Now, if my CA is greater than K, again same, my and value is very big, so I need to decrease my and value. So to decrease my and value, what I need to do? I need to increase the range. Means I need to shift here. This is small range, I need to increase this range. So I need to shift my L toward this. I need to increase the range. I need to increase it starting from here, starting from this R. So what I will do? I will do this. L is equal to n plus 1. So these three steps at last will give me my answer. And initially my answer will be minus 1. My answer will be minus 1. So if my answer is equal to minus 1, answer after doing all the binary search, my answer is still minus 1. I know I never found this condition, means I don't have any subarray starting from index I whose and equal to minus 1. So what I need to return? I need to return minus 1. I will simply return minus 1. But if I return minus 1, then see one thing carefully. Do I need to find E2? Do I need to find E2? If I know there does not exist any subarray whose and equal to K, I don't need to find E2. I can just continue to next start index. But if I found A1, then my fourth step is to find E2. Now fourth step is to find P2 starting from index I. This is my last index, n minus 1. This is some mid. Range will be same here. Just let me change color for better. Okay. Now range will be same here as well. M, sorry, not M, but I, and R is equal to n minus 1. Any range I can have from here to here. Like suppose my K is 2 and this is 2, 1, 1. Then starting from here, this is the starting point, this is the ending point. This is the only subarray. Like this is the ending point starting from 2, ending at 2. Okay, or one more example I need to take. 2, not 2, 3, 2, 1. Starting from here, my end value is 2, K is 2. Starting from here, this is the only subarray. So this will be my even, this will be my E2. This is the only. So I got only one subarray because the end of this will be 0. So this 3 is my only array. Okay, I need to do this. Okay, now come back to the portion. This is my L, this is my R. Now I will calculate my M. Note this color does not suit. I think let's change the color and increase the. I find M. I find M. Now current, what will be current? This particular end value is current. If this CA equal to K, I again have three condition. This CA less than K, this current greater than K. If this CA equal to K means this can be a possible answer. This can be my possible answer. So answer is equal to M. Now I know this and value, this particular subarray and value equal to K. So I need to find the farthest point. So I need to move here. I need to move this side to find the other range, to find the other maximum point, other maximum index till which my subarray is same, my subarray end is same. So I need to increase my range. I will gonna do M plus 1. Now if my subarray is less than K, so and value is less, it means I need to increase my and value. To increase my and value, what I need to do? I need to decrease my range. Decrease my range means I need to decrease this. This is my and range. This is my range. I need to decrease this. Decrease means I need to shift M here. Means I will do R is equal to M minus 1. And value more means I need to decrease and value. To decrease and value, I will increase my range. I will increase my range. Shift M toward here. L is equal to M plus 1. Okay, this is final. So let me copy paste both the part. This is my current code. This is my above code. Code for finding starting point, starting end point. This is my starting end point. Like this is start point means this is start point of my subarray. Like this is for E1, this is for E2. Okay, and this one is for this one for no. Tell for this. This is my E for E2. If my CA is equal to K, answer is equal to M, L is equal to M plus 1. If my CA less than K, CA less than K, if my CA greater than K, the current, CA greater than K, L is equal to M plus 1, L is equal to M plus 1. Otherwise, third condition is this, R is equal to M minus 1, R is equal to M minus 1. Now, for this starting endpoint, like E1, if my end is equal to K, answer is equal to M, R is equal to M minus 1. If my CA less than K, if I CA greater than K, this condition CA greater than K, L is equal to M plus 1, L is equal to M plus 1. Otherwise, third condition, R is equal to M minus 1, R is equal to M minus 1. Both the condition are sure. Now, how to find this current? How to find this current? This. How to find this current? This current. I cannot do a loop like give me and from here to here. So here I have two way. Fifth step is finding CA value or AND value, AND of subarray, AND of subarray. So I have two value. I have two way. Like I have one way of doing using any data structure, like sparse table, using segment tree, etc. But I am not using these any trick. I am just simply use a DP array. How DP array? Like suppose, tell me one thing. I need to find and value of here to here. So what I need to find out basically, I need to find out for any ith bit, when this ith bit will come in my answer of and when this ith bit will be in my and value of this whole subarray. Like suppose I have five value a1, a2, four value suppose a3, a4, and I am saying my and value ca is a1 and a2 and a3 and a4. This is what I am saying. So how can I say that ith bit will exist in my answer? How will I say ith bit? Ith bit will exist in my answer if a1, A2, A3, A4 both contain this ith bit. Means a bit will be in CA if this bit comes in every number of my subarray. So what can I say? If I count the number of bits, if I count the number of bits, like for ith bit, I can say if count of I bit from here to here is equal to number of element I have here. Like if count of bit is equal to 4, means ith bit comes in this particular range 4 times. I have number 4. It means it comes in all number. So it means this ith bit will be in my CA. What I am saying? What I am saying again. Suppose this is, I am again taking example, a big example. Like suppose this is 2, this is 3, this is 6, and suppose this is 10. I am finding for bit 2 whether bit 2 will come. Bit 2 means 2 raised to the power 1, means first bit comes in this, comes in this, comes in this, comes in this. 8 plus 2, 4 plus 2, 1 plus 2, 2. So I can say second bit will come in my CA. Second bit will come in my CA. I don't need to take AND, but I can take here. Suppose my count of bit is x plus 4. Uh, count of bit till here. Count of bit till here is x. Count of second bit, like count of first bit whose value is 2, till here is x, and till here is x plus 4. So I can easily found by subtracting this from this. I will got 4, like 4 extra bit. Here I have x bit till here, x plus 1. Here I will have x plus 1 bit, x plus 2, 3, 4. I have 4 bits, so I can say I have 4 bit. So every number contains this bit. So this bit will be, this bit will come in my answer, will come in my end of this particular subarray. Okay guys, so I can just calculate using a DP. Now how I am calculating it, let's see. Now let's move on to the code. This is I write to like whether I got TLE or not. So that's why I was doing a contest after a long time. So that's why, just to be on safe side. This is my n number of element. Now I am taking vector. Now what is dpij? Dpn. N is the ith index. 30 is the number of bit. My range can be up to 199. So I have take 30 bits because 2 raised to power 30 is greater than 199. So maximum bit number 29 will come in my answer. So what I am saying here, DPI, what is my DPI? DPij, what is my DPI? It's nothing but basically count of gth bit, count of gth bit, count of gth bit till index I, till index I, count of gth bit till index I. This is my DPI. Okay, nothing. So what I am doing for all the number, for all the bits, if this bit is come in my ith number, if this particular bit, gth bit come in my ith number, so my DPI will be 1 plus, why 1 plus? Because it is already coming in this particular number. Otherwise, if this is not coming, this will be this. This will be this. Okay, I plus this. If you are confusing here, I can do this. DPij is equal to 1, and I can write this DPij plus is equal to this. Why? If this bit comes into my VO5, my DPij will be this, and I need to store. Here I am setting whether this bit is comes in my ith, in my ith number or no, in my ith number or no. And here I am setting, here I am setting bit sum from 0 to I. Here it will contain, here I am just pointing whether DPij will be 1 or not, means ith number contains gth bit or not. Here I am saying add all the previous count as well, so I don't need to again turn a loop and all these things. Okay, to save our one more loop. Okay, so I am saying that it will contain the sum of all previous bits. So why this? If my ith index exists, meant it is not equal to 0, I have some previous number, so add till there, otherwise add 0, because my I is 0, it is the first number. Okay, as simple as that. Now answer is equal to 0 for all the starting point from I to n. I am finding this is my E1, this is my E1, this is my E2. If L is equal to -1, means this is my L is even like this. L is my E1, this is my E2. So I just name variable in the context. Now even e2 is to make you understand in a better way. If my L is equal to -1, this L is basically even, like I don't have any subarray whose end is equal to k. I just need to continue. Otherwise, I need to find the last ending point as well, and I need to add this particular sum, because these particular are the possible subarrays starting from index I, whose end value is equal to k. At last, I need to return answer. Now start index is simple. Now how I am calculating? Let's see. This is my I2 and -1 is range. Initialize answer with -1. If my L greater than equal to R, what I am this is just a binary search, finding a mid element. This is for finding the number of element I need, length. Number of, why I am finding length? My count of ith bit should be equal to length, my count of any bit. Now just see, cur is my 0. I am taking 0. I don't have anything. Now for all the bit I am checking if the count of this particular bit from m to I, from m to I, count of gth bit equal to length. Again, I am, if my I, like my I starting point, I will not have any previous number, so it's 0. Otherwise, subtract the previous count of bits, because I don't need that number, those number. If count of those bits from my I to m equal to length, add this particular value in my curve. This particular bit, make this particular bit set in my answer in my curve end value, because this will comes in my subarray end. Okay, this is basic thing. So these are the three things that I already explained. Same here, same here as well. This is the finding of and this is finding the condition that I already explained. So this is the solution. I hope you like it. This is somehow complex because the point it has 7. It is 7 mark problem, also a hard problem. Okay, I got rank 458. So like it took me around 20-25 minutes. I was giving contest after a long time, so maybe that's the reason. Otherwise, I don't find this one so hard. Just a normal binary search and implementation. This finding and part is, I think, the main thing here, to remove the log and complexity of sparse, table, or segmentary. I think that's the main thing here. So guys, if you have any doubt, you can just comment out. I will try my best to explain you. Please like the video and subscribe the channel, because it will gives me motivation to make more these type of videos. So thank you for watching this, guys. Stay tuned.